Before we move on to example 3, I want to think about why we looked at the continuity of f at x equals 2. So 2x and x squared are both continuous functions. So the only way that we could end up with a discontinuity here is where these two functions meet up, and that's at x equals 2. That's the only potential problematic point. And so the same thing could be said about this one down here. The only issue could be where these meet up, and this is at x equals pi. Now, another thing to point out is it would be silly then to ask us to determine whether this piecewise function is continuous at some other point other than pi, because it definitely is continuous everywhere except maybe at pi. And the reason I know that, again, is cosine of x plus 1 minus 1/2 and sine of x. They are continuous functions. So let's take care of the first one on the checklist here. And we're using g here, so let's see if g of pi is defined. So g of pi should be given by this middle rule here, so minus 1/2. Next, we want to look at our limit as x approaches pi. And before we can figure out what this limit is, we're going to need to look at the left hand and right hand limit. There we go. So if we're approaching from the right, we're going to be on the sine of x function. So this is sine of pi, which is 0. And then the next one here, if we're coming from the left of pi, we're going to be on this function. So cosine of pi plus 1. And cosine of pi is -1, so we have -1 plus 1, so this is 0. So the limit does exist. We just have one little problem. The third part of the checklist states that this limit needs to be equivalent to g of pi. And you can see that one of these is minus 1/2 while the other one's 0, so these are not equal. And since they're not equal, we can conclude that g of x is not continuous at x equals pi. Example 4, explain why f of x, graph below, is not continuous at x equals -2 and x equals 3. And is what I mean by explain is we're going to figure out which of the three rules from the continuity checklist are not satisfied. Which one of those rules are not satisfied? So let's start off with x equals -2. So you might already see what the issue is. It doesn't satisfy actually any of the conditions. Our limit does not exist as x approaches -2, and f of -2 is undefined. So we could just make this easy and say just one of these. We don't need all of them to not be true. We just need one of them to not be true, and it's not continuous. So since f of -2 is undefined, f of x is not continuous at x equals -2. And let's look at this one. So it is defined at 3, right? F of 3 is 1, but this time the limit doesn't exist. So and our function name here is f. So since this limit does not exist, f of x is not continuous at x equals 3. Okay. And we know that it doesn't exist because the left-hand limit here, it actually, I can't tell if it, actually it doesn't look like that dot gets quite to 3. But the point is the left-hand limit, it's approximately 3, while the right-hand limit is equal to 1. Right? And so those aren't equal, so this limit doesn't exist. I mentioned earlier that we were going to look at the definition of the interval of continuity in a little bit more detail, and we're going to do that right now. So our first thing here is the left endpoint A is included in the interval of continuity if the limit as x approaches A from the right of f of x is equal to f of A. And the right endpoint B is included in the interval of continuity if the limit as x approaches B from the left of f of x is equal to f of B. And sometimes we'll call this right continuous. And this one here, left continuous. A function f is continuous on an interval if it is continuous at every point in the interval. And if f is defined only on one side of an endpoint of the interval, we understand continuous at the endpoint to mean continuous from the left or continuous from the right. So you're probably starting to wonder, what does all this mean here in front of us? What do all these words mean? So here's the idea. Our interval of continuity, the interior points, the points on the inside of that interval, they have the property that you would expect. They have to be continuous at all those points inside the interval, meaning they satisfy the 3 conditions in our continuity checklist. Okay. But the points on the edge of the interval, okay, so the endpoints, we are loosening the restriction a little bit. And we'll look at a picture of this here in a minute, and you might understand why we might do this here in a moment. But we're requiring our left endpoint to only satisfy this first condition, and we want our right endpoint to satisfy this one. And again, those conditions are a little weaker than continuity for the points inside the interval. All right, so here's an example that's going to help us understand why we might have chosen to do this. Okay. So I'm going to start off with just sketching in a set of axes here. And I'm only going to make a rough sketch of this graph here. So this should look like the square root of x, but just shifted over to the right 3 units. Okay, so the square root of x minus 3, it looks something like this. Okay. And so just looking at, or if we're wondering where it's continuous, we know for a fact that this thing is continuous at least from 3 to infinity. But the question is, do we want to include this point 3 here? Okay. Well, think about it this way. We can still draw this without lifting our pencil, whether we start at 3 or after 3. Okay. So that's kind of the idea here. And so our interval of continuity is actually going to be 3 to infinity. And let's actually check those conditions that we were talking about. So we want to make sure that essentially this thing is continuous as we approach 3 from the right. So we're going to want to take that right-hand limit, the limit as x approaches 3 of f of x, and again from the right. And you can see that as we do approach this from the right, this is approaching 0. Okay. And this also happens to be what f of 3 is equal to. F of 3 is equal to 0 if you plug it into this function. Okay. So is what that tells me is that the limit as x approaches 3 from the right of f of x is equal to f of 3. Okay. And so that's why we're going to include x equals 3 in our interval of continuity.